nanoHUB.org.
Online simulation and more for nanotechnology.
It's my pleasure to introduce our speaker today, Gaby Arellano-Bello, that's how I would say it. She holds a bachelor's and a master's degree, and during her academic and professional career, focused on data analytics project and creating apps using MATLAB. She's currently a customer success engineer at MathWorks, and she supports academics with their teaching and research needs in the US and in Latin American universities. So this is our second workshop on MATLAB. Gen Sasaki, that you see there on the introductory slide, gave a very interesting seminar last week. And if you missed that seminar, the seminar is going to be, the recorded version will be available, and so will Gaby's. So you can come back, and sometimes it's hard to follow the hands-on parts of these workshops because by necessity we tend to go a little fast. So go back, watch the recording. You can stop it and make sure you can follow through. So without further ado, Gaby, take it away.
Thank you, Alejandro. So to get started, there are different ways for you to access MATLAB. And for those of you that have been using it forever, you probably have been using it on the desktop. But there's also the option to use it online. So this is really helpful, especially for students or for people that don't have a computer with the resources to install MATLAB. And also, you can use MATLAB Mobile in your tablet or your phone. So the other good news is that you can also access MATLAB on the nanoHUB. So if you don't currently have a MATLAB license, that's okay. You can take advantage of the resources that are already in the nanoHUB. So this is what we will be using today to do our demo. And you will be going into this launch tool option. But just wanted to let you know that there is a lot of materials here, a lot of resources to help you get started. So this is a really good place to go and to looking for some information. So we will be launching the tool, and it'll take a little bit to open. That's fine. It will take a few seconds. And you see that there is also options to upload your own code and to download the code that you will be using. So we already uploaded the code for you, so you can either follow along or you can explore it later. So I wanted to make sure that we all have access before I move with the presentation. So as I mentioned, it will take a little bit to open, and you will see a few scripts that it will open automatically. So these are there to help you get started, and it has a lot of information. We will not be using them today, but I just wanted to let you know that these are available. It says the presenter is sharing content with 4K, but you can view it in the web app. Do you want to switch to desktop app so you can view the shared content? So what I can do is to show you how to access this in the nanoHUB. And if it's easier, I can just use my desktop version of MATLAB to show you, and it'll look very similar. So when you use the nanoHUB, one thing that you can do is to modify the size so that you can use your full screen and use all the resources that you have available. And this is just to show you how to get there. We will come back in a minute. If the person that shared that information about using the web app versus the desktop can let me know a bit more about what do you mean, that would be super helpful to figure out the next steps. Okay. So the way that we will schedule this presentation today is that, organize this presentation. First, we will talk about some of the machine learning fundamentals to make sure that we have the basics covered. And then we'll spend most of our time in MATLAB doing a hands-on exercise. And then at the end, I'll share some resources to help you go further and some interesting materials that you can take a look at after this call. And then we'll share some call to actions or some action items for next steps. So the goal for today will be to develop a predictive model using machine learning. And in this case, we're going to predict the fuel consumption of vehicles in miles per gallon, right? So if you don't care about cars, that is totally fine. We will not be going into details about car stuff, right? This is just an example to help you follow and understand the workflow and understand how you can use these tools to help you with that machine learning workflow. So again, as we go into this presentation, what I want you to do is to think about your own data, your own projects, and think about how this workflow can apply to your projects. So let's talk, before we go into that example, let's talk about machine learning fundamentals, right? And you might have heard about AI everywhere, and you might be thinking, okay, yeah, this is something, it's a worldwide trend. What is it about, right? And it's actually everywhere, from like the series or like your, I don't know, the Alexas on your house, right? Or smart thermostats. It's absolutely everywhere. But what is it, right? So when we talk about AI, we talk pretty much about the capability of a machine to be able to imitate intelligent human behavior, right? So, and when this gets really interesting is when actually machines can match or exceed that intelligent human behavior, right? Because now we can get machines to do tasks that might be boring or like repetitive, and then we as humans get bored and make mistakes, right? And computers don't do that. And also we can use this type of technology to do perform activities or tasks that may not be safe for humans, right? So now, today, what we think about when we talk about AI is to do this by training a machine to learn this desired behavior. So what do I mean by this, right? So there are two ways in which we can get a computer to do what we want. So we think about the traditional way, we have data and we have a program, right, with a set of instructions, and we feed that to a computer and we get an output. But when we talk about machine learning, this actually gets flipped, right? So we have the data, we have the desired output, and we want the computer to give us a program, right? And it's actually technically not accurate to talk about programs. Here we talk about models, right? So these machine learning techniques follow under the umbrella of artificial intelligence. So if we want to take a look at this in a time scale, we see that these AI concepts actually were born with the dawn of computing, right, in the 50s. And then in the 80s, these machine learning techniques became more popular as they were, again, learning from the data directly without us having to actually write a program to follow the different instructions, right? And then deep learning techniques became very popular in the 2000s, in which we use neural networks. And these pretty much have the structure of, or the architecture is similar to how our brains work and how they learn, right? Okay, so we talk about what is AI, and we talk about like, okay, different types of, like different subsets of AI. But let's talk now about types of machine learning, right? So you might have heard about supervised and unsupervised learning. So what do this mean? So supervised learning is when we have the output and the input, right? So let's say that I want to train a model to differentiate between cats and dogs, right? So I have a lot of pictures from my friends for cats and dogs, and I know which ones are cats and which ones are dogs, right? I have them labeled. So my computer knows, okay, which ones are dogs, which ones are cats, and can learn from that. In the case of unsupervised learning, I don't have the output. So in this case, these algorithms find ways of clustering or grouping my data to analyze it, right, and find those trends or those clusters. So we will not be focused today on unsupervised learning. I just wanted to let you know the types of learning. So today we'll be talking about regression and regression models. So when we have a regression problem, we have a continuum of data, right? So let's say that I want to predict temperatures, right? So it can be 20 degrees or it can be 20.2, right? So it's along a continuum of data. when we talk about classification problem, it's kind of like the example of the cats and dogs, right? We want to classify into different categories. Or in the case of a smart tracker or smart fitness tracker, where you can have categories of like you're running, you're sitting, you're swimming, right? So for today's example, we will be working on a regression problem, right? We have a continuum of data for MPGs, and that's what we will be focusing on. But again, I wanted to let you know what types of problems we can work with this machine learning. And here are some of the examples of models. There are models being developed all the time, but I just wanted to use this slide as a reference, and we'll be sharing a link to the slides, so you have this for your future reference. Okay, so when we talk about machine learning, we don't only talk about models, right? We refer to the whole workflow. And this is what we will be covering today. So first, of course, we need to access data, right? We're talking about these models learning from data. So this data can take many forms. Today, we will be using a CSV file, but maybe you're working with images, or maybe you're working with signals, right? Or you might be streaming data from the web or reading from sensors. There are many ways in which we can be accessing data. So I have some bad news for you. Data is messy, right? Like the world is messy. So we have to actually process that data, right? And if you have worked with perfect data, I'm really jealous of you, because this usually takes a lot of time, right? To figure out what to do with our messy data. And this is where your expertise come into place, right? You're the expert of your data, so you can think about what to do if you have missing data, for example, right? Do you want to get rid of the whole of that data, or do you want to interpolate or try to see what's the best way of approaching this, right? And again, it will depend on your specific problem. This is where we can also do feature extractions. So you might be thinking, okay, what is this feature extraction? What do you mean when we talk about features? So in this example, we can see that there are different vessels. So let's say that I want to create a model to differentiate between different vessels. So one of the features can be if it has a handle, right? Or if it has two handles or doesn't have handles. So that could be my feature, right? What is that the model needs to look at that is important to create this, the model, or what the computer needs to look at to create the model. Okay, so now that we have processed our data, we need to create our model, right? This is what we want to do. So here is where we will try different models. We might want to tweak them, right? And of course, we need to validate them. We need to make sure that they're doing what they're supposed to do. And then once we come to this step, maybe if we stop here, we would have had a lot of fun, right? We might be super proud of the amazing model that we created, but maybe we want to share it, right? So this is where the last step comes in. Maybe you want to create an app so others can replicate what you did with their own data. Or maybe you're working on a model for a self-driving car that would represent or will classify if there's a pedestrian, right? And you can embed that into a hardware, right? So we will not be covering this last step today, but I will be sharing some resources so you can learn more about it in case that you're interested. And as you can see, this is not a straightforward process, right? There's a lot of iteration that will happen here. So this is why I added these arrows, right? Because maybe you're in the developing the model process and then you realize that you need more data, right? So you have to go back and get new data. Or maybe you realize that you need to work with other features, so you go back to this step. So it's an iterative process, and that's the nature of it. But one thing to highlight here is that you can do all of this within MATLAB within the same platform, and that there are a lot of tools to help you make this process easier. So we will be seeing some of these today. So at its core, we're talking about training these models, right? So we have our data, we're processing our data, we're developing these models, and there's some iterations that we have to do. But once we have our model, now we want to do the prediction, right? In our case, it's MPG, but it can be, I don't know, the temperatures, right? So once we have new data, we need to, again, do some of that, the same pre-processing, and then we'll use the model to generate that prediction. So enough of PowerPoints. We can talk about going into MATLAB. So just a reminder, we will be using, we will be creating a model to predict a vehicle consumption, and we will be using this data set in CSV format. So let's try it out. So when you open MATLAB on your nanoHUB, it'll open this template. So I will be just closing them today since we are not going to be using them. Okay, so you'll see here on the corner that it says current folder, and there's a folder called workshops. So let's go there and select the first one, machine learning with MATLAB. Let me just zoom this a bit more. And we will be working on this solution folder. So there's two. The work folder doesn't have the results, right, the solution. So I encourage you to take a look at them after the presentation so you can play with it and try to solve it on your own. But to save some time, we will be working on top of the solution. So open this machine learning workshop solution. And I'm going to maximize this for a little bit. Okay, so we're seeing here a live script. So yes, a live script is a document. I like to see it like an interactive notebook, right? Where you can have text with format. You see that there's a table of contents that I generated that it automatically created hyperlinks to the different sections. And I can incorporate images and text with format so I can create a narrative around my code, which makes it easier to share with others, and also for myself to remember what did I do, what was it that I did when I created this, right? And you see that here with the background in gray is the code. So this is what it actually gets executed, right? So we talked about the first step being to access the data. And there are different ways of doing this. So you can write code to do that. There are a lot of functions, but my favorite way of doing this is by using this import tool. So when I click on it, it gives me the option to select what is the data that I will be using. And you see that there's a lot of different data files or data formats that I can use. In this case, we will be using this CSV file. And what it opens is a preview of my data, right? So I can use this tool to do some exploration. But also, probably it's a case for you that you're working with data and that you don't use the whole data set, right? So here we can start selecting what is the data that we will be using today. So let's say that I want to use the acceleration, displacement, and here I'm just selecting a few that I know we will be using. And here you can explore like different outputs that you can generate here. There's some pre-processing that you can do to figure out what to do with cells that are missing. But I'm not going to go into a lot of detail here because we will be doing some pre-processing later on. But you can explore this on your own time as well. I shared some links also in case that you want to learn more about this tool. So once you have selected your different columns, you can import the selection and it will read directly into MATLAB. But let's say that you want to make sure that you can replicate what you did here in the future and you don't have to, again, select all the columns. Maybe you have new data, right? And you don't want to go under and repeat this, even though it's really simple, it's really easy, but you want to make sure that you don't forget to select the same columns or something like that, right? So what we can do here is to actually generate a function. So, I mean, there are different options. You can generate a script or function. In this case, I decided to generate a function. So I can just reuse it with different file names, right? So the function allows me to change the inputs so I can reuse it with different files. And you see that MATLAB wrote the code for me. So once this code is generated, this is yours. You can modify it, you can copy, or you can use it to learn about what MATLAB did. So it's a really good tool to help you automate these processes, but also to learn about the code itself, or even take it to a next level, maybe add some functionality to this code. So you can save this, and because we're working on the solution, I already saved one that I created yesterday that is called import data. So if you take a look, this is my workspace. So this is where I'm going to be having my data, and it's empty right now. But once I click on the code and I go to Live Editor, I can run this section. So it will run the code with that function that I created and saved. And it's reading that car data. So I have a preview here. I can see, okay, it has 400 columns, rows and 7 columns. And I can do some exploration in here as well. And as I mentioned, this is one of the ways to do this. You can write code to do so. That's totally fine. Some people just prefer to work with code. And one of the things that we can do here is to show you the documentation, right? Because one of the functions that we can use is this read table. So let's do something together first. Let's go to Home and Preferences. And we'll go to the help. Because here for the nanoHUB, we need to make sure that we have the documentation installed locally so we can access it, since it doesn't allow us to go outside and check on a website. So this is really important in case that you want to access the documentation inside the nanoHUB. And it's a simple step. Once you do that, you can just access the documentation as you would traditionally. So I can search for read table, for example, and you see that it tells me that it's a function. And here in the documentation, I can explore, right? Like, what is it? How do I use this function, right? We see that it's organized always in the same sections, so you always know where to find information. So for example, under description, you can find examples, which is my favorite part, because maybe you don't want to spend too much time going through the details. Maybe you just want to see if there's an example that does what you're actually looking to do. And you can copy this code, or you can open a live script, you can modify it. Again, you can use this to learn more and to reuse it for your own application. So you see that there are different sections that you can explore, and like inputs, output arguments, so you can go into more depth. But one of my favorite sections is also this see also, because maybe this function doesn't do what you're looking to do. And that's fine. You might try to see maybe import tool will help you for that, or maybe you want to use the function table, right? So you can explore here other options. And also under topics, there's a plethora of information. So it's not only about, okay, how does a function work, but it's about a lot of information about how to, in general, do things in MATLAB. So like you see that it's separated into like language fundamentals, data types. So I really, really encourage you to utilize the documentation. We have an amazing group of people that are working into making sure that this is as easy to use as possible. Okay, so now that we read our data and we look at the documentation and learn about how to find more information, let's talk about pre-processing our data, right? We talk about this data not being perfect. So one of the things that we can do is to create a summary and see if we can find any flags in there, right? So you see that this summary covers all of the columns in the table. So you see some of the information, the minimum, the median, the max. So here, let's say, for example, if you had a horsepower that the minimum is negative, so that's a flag, right? That's something, tells you that something's wrong with your data. So this is a place where we can start looking into some of those trends and some of those that information. We can see that there's some missing data, right? So we can start thinking, okay, what are we going to do about this missing data? And I added here some information about things that you can do, questions to ask yourself. And again, this is for you to to explore, this is all yours. It's going to be there available to you. So we will not go into the details here, just letting you know that this is available. Okay, so to cleaning that missing data, right? We saw that there were some missing points. So we can do, again, many things. But one of my favorites is to use a task. So these tasks gives us like a small interface in your script, right? And you see that there are tasks for a lot of functionalities. So there's a lot in pre-processing, like cleaning missing data, smoothing the data, but there are also tasks in other areas. And with each of our updates, we keep, or new releases, we keep updating and adding new tasks. So I added one here, that clean missing data. And again, you have all those steps, so you can follow along or follow later. And as you can see, we can manually select the different options here, the different variables that we want to use. So for example, we know what our input, we wanted it to be the car data, right? But also, how do we want to process this? Do we want to save a separate copy of our data? Do we want to just extract the MPG information? So here it gives us a lot of flexibility about what we want to do. And let's say then instead of removing the missing values, I want to fill on the missing information. So I have a lot of options. Maybe depending on my data, a linear interpolation is just fine. Or maybe I want to explore things like the nearest value, right? So there, again, this is where your expertise in the data, with your data and your problem comes to play, right? And you can try different things and see how they work on this app. You can see that it generates a code for me, but I can choose to hide it. I'm going to hide the code to make this easier to see. But now we see on our plot with our data, what are the points that we're filling or that we're deleting, right? So that gives us some information about, let me just put remove missing so I don't forget to do this. It gives us some information about where are those missing values, right? So we can explore our data in more detail and make those decisions. Okay, so just like we did this missing data and we did the summary, there are other ways of exploring your data. And one of them is, of course, creating plots. So there's a task to do so. So if you go to create plot, here it is, you can include this task and select different plots and explore with that. So this is your homework or part of your homework since we don't have a lot of time, but I just wanted to show you that there are options to generate different types of plots. And there are a lot of pre-existing types of plots that you can use for your projects. So then I'm going to finalize the data by just moving this MPG to the end of the table. And I'm only doing this because machine learning capabilities that MATLAB has assume that the predictor is on the last column. And it just makes your lives easier as we continue on this process. But there are ways of just like overwriting or just changing and manually selecting which one is your predictor. But just to make it easier today, I just moved it to the end.
Somebody did ask the meaning of MPG.
Oh, miles per gallon. Sorry. Yes. You should have mentioned that. Yes. Okay. So so now we cleaned our data, right? And there are different things that you can do to clean your data, but this is just an example, right, of some of the things that you can do. So now that we are ready to train our model, we want to make sure that we have some data saved to test it, right? We want to make sure that the model is doing what it's supposed to do. So what we can do is separate it, right? And so you'll see that we will refer to training data. So this is, like the name implies, the data that we're using for training the model. We have the testing data, that it's the data that the model is not seeing, right? We're like hiding it from the model. And then sometimes it's useful to use validation data. So this is it's different from the test data in the sense that it's actually seen as we train the model. So this helps us prevent overfitting. And when we talk about overfitting, we talk about like having a model that learns like so much from the data, just focuses on that existing data, but does not, does not work for other sets of data necessarily. So one example that I like to use is, let's say that you're a student and you're working and you're studying for your exam and you're just studying a one type of exercise, right? And then when the exam comes, sure, you'll do amazing on those exercises, but you probably won't do so well in the other type of examples, right? So this is what we want to avoid when we want to avoid overfitting our model. So here we are going to first separate the data set, right? So we can make sure to separate into training and testing data. And here I added the option to have a drop-down menu. Let's say that we want to share this with a coworker and they want to try different percentages of data that we're going to set apart. So they can do that and select it easily without them having to go through the code and finding where is it that they need to make those changes. So here we're just separating this into, like, we're separating 20% of our data for testing. And we're using some existing functions that allow you to do that very easily. And also to select different types of techniques to separate your data. So here, this section is just pretty much separating those sets. So we have the trained data, right, that has 319 data points. And then we have our training data training data and our test data that has 79 points. So this is a very small data set, but I wanted it to have it small so we can play around with it and make it fast for us, right? And as you may know, this is just to show you an example of how to go around solving these problems. So now that we have pre-processed our data and we have separated this, now we're ready to train it. And there are different ways in which we can do that. And one of them is to use an app. So these are actually, I think these are very underutilized. There's a lot of apps that pretty much are a user interface that allows you to follow a technical workflow, right, in an interactive way. So you see that they are separated into different areas. So for example, machine learning and deep learning, which is what we will be focusing on today. But maybe you're working on signal processing or I don't know, image processing. So there are a lot of apps that can help you with that. So today we will be using this regression learner because we are using a regression problem. And so that makes sense. So I see Martin asked us, what is the difference between an app and a task? That is a really good question. So you saw that the task, we can have it in our code, right? So it's on our script. So it is in line with everything. Whereas the app, it's a separate interface that we're using. And we can always generate code from this interface and incorporate it into our script. But the way that we interact with these apps is separate from the script. I don't know if that answered your question, but yeah, feel free to let me know in the chat. Awesome. Okay, so now we see that this app open, and you see that I only have one option here. So in that sense, apps are very intuitive because I can see easily what is the next step that I need to do. So I have my data from the workspace. And so it might take a little bit to open. And now we see that it will allow me to select the data. So this is the data that I have on my workspace. And we have this trained data, right? So this is what we're using to train. And you see that it automatically selected MPG, or miles per gallon, which is the predictor that we'll be using. And this is because we had moved it, if you remember, to the end of the table. But you can manually select which is the predictor that you want to use. And then you can the response. So then you can select the different features that you want to use. So let's say acceleration, and you can just unselect them. And again, if you have questions, you see these links here. So there's a lot of information on the documentation. And in this case, we are just using the predetermined validation option, but you can always explore using others depending on your problem. And now we go into the regression learner. So you can see here, let me just maximize this. There's a list of models, right? So if you're totally new to machine learning and you see these models and you want to go run away from them, please don't do that. That is totally fine, right? And we could potentially train them all and see how they did, and then go into seeing which ones perform better and take a deeper dive into those models, right? So a really good place to get started is like selecting all quick to train, right? So it will select the models that are, like the name implies, quicker to train. And you can select the option to just train them. So I'll do that, and it'll take a few seconds. Okay, so let's say that I select that all quick to train, and I train my models. Okay, so now we see that they are queued, so they will be trained in order. And you see that as they get trained, I start getting the results. So I see that it highlighted the one with the lowest root mean square error. And I can always go into more details here into training results. So you can use this information to make decisions about this model and whether it's one that is suitable to you, right? And also, we can start using different graphs to take a look at how they perform, right? So I can explore in this interface. Okay, let's see, I want to take a look at what is the predicted versus actual performance, right? So that gives me more information. Of course, I want the data points to be as close as possible to this one-to-one line. But I also can use like residuals to analyze and see maybe which parts of the data this model performs better or not. So there's a lot of things that I can do in this app to help me make those decisions about, okay, how is this model performing and how can I improve it, right? So we also talk about data that we had separated for testing it, right? And right now we're not using it, we're just using validation data. So what we can do here is to import our data from the workspace and select what is our test data that we want to use to compare.
Yeah, one specific question was on hyperparameters.
Oh, yes. So there's a lot of advanced tuning that we can do in these models. And of course, it will depend on the type of model. Okay, so, and we can learn about how to debug also and stop the execution. So here, what I'm doing is just run to here, and it will run the whole script until that line. So I really like to use that when I'm debugging. So then I can execute this regression learner. So that's also a way of opening these apps. So they have a command in MATLAB. So if you don't want to go and look for the app on the apps tab, you can always type the code and open it that way. So this is what it did in here. It opened the app. And now we have from workspace. And we have the train data, just like we had done in the past. Okay, and I'm going to just train one just to show you, so we can save some time in there. But as I mentioned, you can train different models, or you can train them all. And in case then you have a lot of data and it takes a long time to train, you can also use parallel computing. So if you're working with GPUs, or you have, well, you probably have multiple cores on your computer, you can take advantage of those and do these calculations in parallel, so you can save some time in there. And now for test data, we will be reading this from the workspace, the data that we had saved. And now we can test them all, right? So in this case, we only have one model, but we can then look at the test results in a graph format, right? So you can take a look at, okay, what is the predictions versus the actual results on this data. So again, that gives you more information with the test data that you had separated. So once you're ready, maybe you want to export your model, right? Because we talked about using these models for something to make a prediction, right? So we can export the model, or you can also generate a function. So like in the other apps that we use, we can generate MATLAB code to pretty much replicate the steps that we took interactively into code. And you see that it tells you when it was generated, and it has all that information about what steps to follow. So you can share this code also with your coworkers so they can use this for training their own models or replicating what you did. So I have loaded here a model that you can take a look at, and this is just to show you the metadata that you get from these models and how you can take a look at what's inside. And then we did some evaluation of the model in the app, but you can do this programmatically as well. So this is what this section is doing. It doesn't go into a lot of detail. I mean, I'm not going to go into a lot of detail, but you can play around with this code if you like. And again, we did some visual measurements. We did different visual representation of our data. So we can do this, again, programmatically. And at the end, of course, we need to take a look at that model and maybe do other type of representations, compare it with the performance of other models, maybe seeing if there's any trends. Maybe the model performs very well on a particular, I don't know, from like a set of horsepower, a specific range of horsepower, but doesn't perform so well for larger values, right? So this is where we can start thinking about in making those decisions about the models that we want to use, and how are we going to make those decisions. So this is why I left you with some like things to think about here. And then with these predictions, you might want to share them, right? So we can save them as well. And in this case, we're doing this in an Excel file. And this material was created for a competition initially, for a data science competition. So this is also how you save the results, so you can submit them to the competition, right? And at the end, well, once you rinse and repeat and do those iterations, you're done. But here are some further examples, right? You probably want to go into more depth. So I'm sharing some tutorial video series that are super helpful, go into a lot of detail about these steps, amongst other trainings. So if we go back to the slides, you see that, well, here's the information about the documentation, those steps that we took. So you'll have access to the slides, so you can follow this on your own if you like. And we also talk about this being a workflow, right? We cover every step except the last one. So if you're interested in this last step, there are a lot of resources. So I'm sharing here some of the options. So for example, we can generate code from MATLAB into, like, translate it, let's call it that way, into C or C++ or CUDA if we're working with GPUs, right? Also, we can compile this and create an executable that we can share with others without them having to have MATLAB installed, right? Or maybe we want to use this on a bigger scale, or like a MATLAB app, a web app, right? So there are a lot of options here. So that's why I shared this, even though we didn't go into detail in the presentation. Also, you might be working with other languages, or maybe thinking about using other languages. So MATLAB does have the option to work with other languages, right? So if you're curious about it, there's a lot of information on our website, or you can also reach out to us and we can help you with that. One really, really good resource that I like to highlight are free courses. So these are tutorials. They're all self-paced. And you see then there's this getting started section. So these courses are totally free. You don't have to have a license or anything. And as you can see, they go from like MATLAB Onramp. So for those of you that are totally new, you can take this. It takes about 2 hours to finish. And you can generate a certificate at the end that you can share with the world to show all the cool stuff that you learned, or share like in your resumes. And also, for those of you that are from other places where English may not be your first language, you can also have, and some of these courses are translated into other languages. Okay, so, and this is for MATLAB Onramp, but let me see, how do I get back here? There are also areas like machine learning, right? So there's a machine learning Onramp that it's totally free that you can take as well. So this is something that I recommend after this presentation if you want to learn more. Those are really good resources. And for those of you that are affiliated with the university, you may have access to other courses that go into more detail. So these take about 2 hours to finish, but there are some that are more like 12 hours of content. Also, we did a similar recording with this content. So it's on YouTube. If you're interested, you can also take a look at those. This was created for that competition that I mentioned, but it applies, of course, to machine learning in general. Also, there's a lot of other resources like Tech Talks if you want to go into the specifics of machine learning, the technical side of things. There are ebooks, cheat sheets, so there's a lot of information there. So I highly, highly encourage you to take a look at it and let us know if there's anything missing. We love to hear your feedback as well. And so as you can imagine, the MATLAB community is enormous. It's very large. So I encourage you to also leverage the MATLAB community. This file exchange is a place where you can share what you have created or look for stuff that others have created. And also, if you create something cool, I recommend that you also share it on nanoHUB, right? There's a MATLAB group that was created for that type of exchanges and that type of community building. So I think it would be really nice if you use that as a platform as well for collaboration and sharing resources. So here's just an example of another community, CIRC, which we collaborate with them very closely, and they have a lot of materials for teaching that they have created throughout the years. So that could be an example of a way of creating this type of community. So as I mentioned, the last thing that I had was a call to action, right? So if you want to learn more, I shared those trainings in which you can use to get started, and also explore our website. There's a lot of information there, a lot of resources, examples, videos that you can take a look at. If you're planning to teach or are teaching, there's an educator's website where you can find, again, a lot of resources. And as we mentioned at the beginning, we have a worldwide team that works with educators around the world. So we're happy to help. Feel free to reach out. And if you have created something with MATLAB and you want to share it with the world, I'm sharing here the materials, the file exchange, and the nanoHUB MATLAB group. And finally, if you're interested in following us and learning more about cool materials or applications, follow us on social media. We have a lot of information there, and we post a lot constantly about things that are interesting to us. So, Alejandro, I don't know if you have any thoughts. I see a lot of questions.
No, well, I'd like to first of all thank you, Gaby, for a terrific workshop. This is really awesome. What we're going to want to make sure we do is all of these links to very valuable resources. We will post them on the group page in nanoHUB, so you have easy access to all of those links. And also on the nanoHUB MATLAB tool, there's also a bunch of interesting links that everyone should follow. If there's a quick question and answer, maybe Gen can share to Gaby.
We do have one that was unanswered. It says, could you please elaborate why the model is predicting higher miles per gallon for the data which is in the middle compared to one which is at the either ends of the graph? for the training data was created. So meaning, what can one interpret about the model about such prediction which is not so uniform?
Okay, so I think it was, yeah, about that specific model. And that's part of the fun, I think, sometimes to see how that performs and see. I think it was for the residuals, probably the plot, where you can see that in some of these, after a certain value of MPG, like the prediction wasn't that good. So this is where you can start thinking about, like, okay, is this model actually good for this, right? Maybe we want to try a different type of model. In this case, we use trees and linear regression. So this might not be super good for this. So I would first start by trying other models and again, seeing how they perform, and maybe do a combination of both, right? Maybe you have one for smaller values and then for larger values. So yeah, there's a lot of trial and error and getting creative in here.
That's a very good point. And there's a lot of research going on in terms of interpretability of these machine learning models that sometimes are treated as black boxes, but many of us are scientists or engineers and would like to understand things. And there's interesting tools coming online. There's one in particular, it's called SHAP analysis that works on random forests and trees, and it depends on the tool. And so I encourage everyone, right, to keep coming. We're going to continue with a series of talks, maybe more from our friends at MATLAB and other researchers. So we'll try to address, these are interesting topics to continue our conversations around. So let's all thank Gaby once more for a terrific presentation. And thanks everyone for calling in.